Hello everyone. In this video, we shall discuss question number 3 and question number 8 from the recent JEE Advanced paper 1. In fact, question number 3, you can see, has stirred quite a debate on the YouTube. There have been a lot of chatter around question number 3, like who gave the correct solution first and what is the actual source of this question and all that. For a student who is already juggling from a short attention span, these kind of things create more confusion than clarity. But honestly, I am not here for this race. I'm not for the speed and not for the show off. I am here only for the clarity. So instead of chasing the answer, let us chase understanding. And my aim is in this video to walk you through a clear, elegant, and mathematical way of thinking so that next time if you face a similar kind of question, you are not just guessing the answer, but you are well prepared. But before we begin, I have a small request to you. I encourage you to attempt these questions before watching this solution, because then only you will understand the solution as well as you understand the importance of this solution. And you must know that the real understanding or real learning happens like this only. All right, let's begin. Alright, so this is the question number 3 here, and the question says that let R be the set of all real numbers and define a function from R to R. The function is defined piecewise for x not equal to 0. This is the definition: 2 minus 2x square minus x square times sine 1 over x, and for x equals to 0 this is 2, and we have to choose which of the following option is true. So I have somewhat made the solution here already written. You see there, the function is given here, fx. So I can write this function in such a way that I'm taking this x squared common from these two terms, and I have 2 there. It means I'm getting this whole quantity subtracted from 2. And now I'm taking a very small number h, and I'm assuming that x equals to negative h. When x is a negative h means x is a negative number because h is already positive. So I'm substituting any value, just a negative quantity, in the function f, and after simple calculation I'm getting this quantity is less than 2. Why? Because this quantity, whatever quantity will come, you're subtracting it from 2, and this is already positive quantity. Why? Because when I'm substituting minus h, the minus sign here will turn into positive sign because of sine of minus theta is minus sine theta. So this will become a positive quantity, and we are subtracting any positive quantity from 2, you will get a number less than 2. So this is less than 2 when we are approaching towards 0 from the left hand side. In the same way, when I'm substituting x equals to h, the value will become again less than 2 because this quantity is again positive. Why so? Here, although there is a negative sign, but sign of whatever value you take as a positive number, you're subtracting from 2, it will become more than 1 only. It's a positive only because sine 1 by h, whatever angle is lying between minus 1 and 1. Alright, so this is clear understanding that whatever value we go from left hand side to 0 or the right hand side to the 0, or we can say in a simple term that the limit we are finding at 0, the value of the function is approaching towards 2 only from the down. It means the function maximum value will be always 2. because when you substitute x equal to 0 there, it is 2 because of the definition, correct? So the maximum value of the function is always 2, that is no doubt. Now they're asking the decreasing and increasing behavior, in what interval the function is exhibiting, that we have to understand. So for that, I have simply differentiated this function, and the function derivative will be this one. I have this function given, and I'm using the first version of it. So if you differentiate this, automatically you know that what will happen. Let me just show you. So f dash x will be what? 0 and minus 4x, and here we have to apply the product rule. So x square I'm keeping, I'm differentiating sine 1 over x, that is cos of 1 by x into negative of 1 by x squared by the chain rule, and plus sine 1 by x into 2x. You can notice that this x square and x square will get cancelled, and after that I'm opening this bracket, so I'll get negative 4x, and this is minus cos 1 by x, and the minus 2x sine 1 by x. So this is our derivative, and I'm writing it here in a simpler way, which is here, and I'm taking this minus 2x common from these two terms to write this thing. The purpose behind it, I'll just show you. Now let's go to the B part, B option. The option says that there is a positive real number delta such that f is a decreasing function on the interval 0 to delta. Now they're not saying that what delta value is, okay? And I'm not going to tell you that graphically is oscillating and all these things. I'm just giving you a very clear understanding. So see, I don't know about a delta, but I know that when you move from 0 to delta towards positive x direction, it simply says that no matter how small delta you will take, there must be an interval between 0 to that delta. The function is decreasing function. So let's just decode this whole thing. So if the function is decreasing after 0, because you notice that the function maximum value already we have got as 2. So before 2, it was also less than, before 0, it was also less than 2. After 0, it is also less than 2. I mean, the function graph will look like that somehow. But it is not only the sufficient condition to tell that the function is decreasing after x equals to 0. We know that the value after 0 is lesser than 2, that's for sure. Means whatever value you take after 0 or before 0, the function will spit out the value lesser than 2, that is for sure. But it doesn't mean that the function is always decreasing. Why? Because it can also give this kind of nature. You see that still the value of the function is lesser than 2, but the function is increasing in this interval and again decreasing. So to confirm this whole idea, we have to think that when the function is decreasing entirely x greater than 0 for, it means the function derivative should be always negative. It means no matter what value you will choose after 0, if the function is decreasing, its derivative will always give you the negative value, because the slope should maintain negative every time entirely up to infinity if the function is decreasing. So let us check for some small values. So here is the derivative, and I'm substituting the value 1 by 2 pi. You can see that the value 1 by 2 pi is a number close to 0 because it's 0 point something. So I have chosen that value, and when I'm substituting this 1 by 2 pi in this function derivative expression, you can see here. So that will give you minus 2 into 1 by 2 pi and into 2 plus sine of 1 by 2 pi. So that will become sine of 2 pi. And this will become cos of 1 by 2 pi. So that will become cos 2 pi. And after simple calculation and everything, sine 2 pi will become 0. Cos 2 pi will become 1. And we are ending up with this negative 2 by pi plus 1. And you know that after this simplification, you get pi minus 2 by pi, which is a positive quantity. It means that I have a number between 0 and delta. Now you say that, oh, delta, how you say that is a more than 1 by 2 pi? I will show that thing also. So if 1 by 2 pi you have chosen, the value is positive. It means there is one number more than 0 at which the function derivative is already positive. But it is saying that the decreasing throughout 0 to delta. But let's see, I have chosen other delta. So here I have also given you the value 1 by 2 pi. F of 1 by 2 pi is this positive value only and lesser than 2. So that is not actually that much important. But let's see a beautiful pattern. I realize that whenever I'm substituting in this x as any even pi, this will become 0, correct or not? Means not even pi means 1 by even pi, I mean to say. It means here I'm going to substitute x equals to 1 by any even pi. It will exhibit the similar kind of calculation or similar kind of a structure what we did for 2 pi. Yes or no? Means 1 by 2 pi. It means that if I'm substituting here f dash 1 by 2 and any number k or any number n 1 by 2k pi, this is going to give you this part is 0, correct? And this part 1. Let me just be more precise. This part will give you 0 and this part give you 1 because it is the calculation you can understand. So minus 2 I can substitute here 1 by 2k pi and 2 plus and sine of what? It will become 2k pi and then plus cos of 2k pi. It means that this value is already 1. This value is already 0, correct? So this is 0 and this is going to be 1. Now I am left with only these things. So what we get here? Minus 1 by k pi yes, and into 2 and plus 1. And what we are going to get here is what? K pi minus 2 by k pi. Already the k value you can take any integer. So suppose I'm taking k as a 1, so automatically the pi minus 2 is a positive quantity. I'm taking the positive direction. When you take k is equal to 2, automatically it's a positive and all. So for k, any k which is more than 0, that will give you the positive quantity only. It means, suppose someone has chosen a very small delta. What is a small delta someone has chosen? Let me just show you. Suppose someone has chosen a very small delta. Let's say delta he has chosen like 1 by, let's say 2 to the power 2000. This is a very small number. But still what we can make, that I will choose my choice of this number I can choose smaller than that, so that it will exhibit the similar kind of calculation. What I mean to say, let's say I have assigned this number as, let's say, epsilon or any number. Let's say epsilon, I'm going to say that is a 1 by, and already I have this even number, so I attach pi there. So 2 into 2000, 2 in pi into 2 to the power 2000 is again this the denominator is even number, means even pi. So if when you substitute that here, automatically this will go 0 and this will go 1. And a similar calculation you'll get, and again you get the positive quantity. It means no matter what you put the lambda, how small you are choosing doesn't matter. We have a chance to choose a number smaller than delta in which the derivative is going to be positive. It means the function will not be entirely decreasing in the interval 0 to delta. There is one more important thing also I want to share. Suppose in this derivative I am going to substitute odd pi. What will happen? So at odd pi what will happen? Let's see. If I choose odd pi, let me just take, so f dash 2k plus 1 pi, not odd pi, I mean to say that the reciprocal of odd pi is a 2k plus 1 pi. And here I have the derivative, so I'm substituting here. I want to see that derivative expression so that I can substitute. Okay, so that is going to be minus 2 and then 2k plus 1 pi, and here 2 plus sine of, it will become 2k plus 1 pi, and this guy will become cos of 2k plus 1 pi. And see what is the beauty of this mathematics is this is going to be 0 again, but this will going to be minus 1, and see, doesn't matter what is this value. So I can say that this is nothing but minus 4 by 2k plus 1 pi and minus 1, and doesn't matter what the value you are taking k for the positive quantity. I am saying k is positive, in that value this is always negative. It means that at every such epsilon which has the denominator even pi, the value of the derivative is positive. And whenever I am saying that the denominator is an odd pi of such epsilon, like 1 by odd pi, if you substitute, the derivative is negative. What is the meaning of this? It simply means that the graph at 0 is giving you the value 2. That's for true. That's actually true. But after that, there is some epsilon, like a 1 by even pi. It has a slope positive. It means it tries to rise above. But when you go a very next odd pi, it will try to fall down. So again, the 1 by even pi, it will try to rise up, and again at 1 by odd pi, it will try to fall down. And that is why the oscillation is happening, and this is the clear understanding of oscillation. Alright, so this is my take here. And okay, by the way, for the third option, you can see that when I'm substituting k is equal to minus lambda here, sorry, not lambda, means k is a negative value, then the same 1 by this 2k pi will give you the entire thing. Oh, here it is, not there, way that, oh, thing here. Okay, so when I take this k negative here in this expression, if k negative, automatically this both sign will become negative, and what will happen, it will become positive again, correct? Because this minus sign you can take common and so on, it will become positive. So for k less than 0 also, the f of 1 by 2k pi will become positive, and for 1 by 2k plus 1 pi, when k is negative, it will become again negative. It means in every 1 by even pi, it is showing the positive slope, and at every 1 by odd pi, it is showing the negative slope. So it is saying that in this third option, that for any positive real number delta, the function is not an increasing function on the interval. It is true actually, because it's not an increasing function, because it's increasing and decreasing also sometimes. So that is the option C is correct. Alright, now my point is, by just taking a very simple examples, is a clear proof that the function is exhibiting the oscillation. In the form of slope, we understood everything. So let me give you the clear picture of this whole thing in the GeoGebra. So let's jump into the GeoGebra. So we are in the GeoGebra now, and I have to adjust my keypad first. Wait. So here I have the function 2 minus 2x squared and minus x square sine 1 by x, sine of 1 by x. And you can see this is the graph we got, and this graph is clearly saying that I have the maximum value 2 there, but you can notice that if I zoom in inside the graph, you can find that oscillation is happening. You can clearly see it's a very close number. I've taken 0.05, you can see there on the x-axis, and here again you zoom in 0.02, again this oscillation is happening. So this is the one thing you can understand from, but you can understand better. Well, how do you understand better? Let's draw the graph of its derivative. So to draw the derivative graph is not so difficult. You have to just hit F dash, and that's it. You can observe that around 0, the graph is actually going up and down, means it is crossing the x-axis countless number of times. It's a kind of a crazy guy who is actually oscillating very fast. So for a very small delta, you cannot say what interval you should take so that you can clearly say that the function is decreasing only. Why? Because the functional derivative is going above axis and below x-axis. It simply tells that the function derivative is positive and negative in a very small interval. You cannot imagine what interval it is, and that's why the function graph is oscillating. Alright, so now we will go for the second question. Alright, so this is question number 8, and in question number 8 what we have to find, there is a function given, and the question is asking the point x equal to 0 is a point of local maxima or local minima, and similarly the number of points of local maxima of f in the interval pi to 6 pi is 3, or the number of points of local minima of f in the interval 2 pi to 4 pi is 1. So my point in this question is that first of all we'll find the limit and all. The 7 by 3, the first part is already okay, that we can say that at x equal to 0 the point of local maxima is correct, because the left hand limit and right hand limit both approaches to 7 by 3, and the function value is also at 0, 7 by 3, but all the values after 0 and less than 0 is lesser than 7 by 3. To find the answer for the third and fourth part, means the local maxima, number of local maxima point and local minima point, there is one catch here. So let's calculate this. Since the derivative I've already done, so to find the local maxima, local minima, we have to find the derivative, so that's why we have done it. So after simplifying this thing, we get here what, 8x and 8x will get cancelled, and we get here 4 sine x, and that is going to be a minus 4x cos x, and this is 2x plus sine x the whole square. We can write it as 4 pi 2x plus sine x the whole square and sine x minus x cos x. Now after this you can find many solutions like this, that they have taken this cos x common from there. So 2x, just 2x plus sine x the whole square, and then I'm taking cos x, so I'm getting here sine x by cos x, that is tan x minus x. And now we have to analyze the sine of this whole thing. And for that, we will draw the graph of tan x from pi to 6 pi, and also the line y is equal to x and so on, and we analyze this thing. In the entire interval of such, I have to also keep eye on this cos x, how it is behaving, the positive and negative. So this is one way to do it. It's a correct way. So my point is, why not we can do it in another way and more effective way. So I have already this f dash x is 4 by this some quantity square, and let's call this whole thing is a gx. But I'm not writing this thing, I'm writing this thing. Okay, so this is going to be sine x minus x cos x. This is sine x minus x cos x. The function's derivative sine means the increasing decreasing behavior of the function is determined by the f dash x sine, correct? So why not we can decide the sine of the f dash x by this function only. You can notice that it doesn't matter what this value will give, it is only going to be positive. So it is not going to contribute in the decision of the sine of f dash x. So I'm saying that is nothing but some other function into gx, like 4 by this square and into gx. It means now the derivative of the function, that is the f dash x, depends on gx. How gx will behave, if we analyze that thing, we can say about f dash x also on the basis of that. So the gx I have is sine x minus x cos x, and we are going to analyze its behavior, means the positive or negative or so on. So let's find the derivative of this function g dash x, and g dash x is easy to find, it is x sine x. Now I have this two data, and on the basis of this I'm going to draw the graph of gx. How do we draw it? Let's see. I have, you notice at 0 this function value is 0 also. The g0 is 0, correct? It means at 0 the function value is 0. And the derivative is also 0. After that, whatever value you take, suppose I'm taking pi by 2. Then I have to take pi, then 3 pi by 2, and then 2 pi. I'm just taking one interval here, and after that we can analyze for the others. So at 0, the function value is 0, means g0 is 0, and g dash 0 is also 0. So it will start lifting from here, because after that every gx value is positive. So it will start lifting from here, and at pi by 2 the value of the function is very easy to find. You see that at pi by 2 this value is 1 and this value is 0. This value is 1, this value is 0. So I'm not writing, but you understand, g pi by 2 is 1, correct? It means at 1 it is going to cross somewhere, at pi by 2 is going to cross somewhere 1, correct? So my graph should be like that. From there it should cross this height 1. But so far we have not found the maximum value of this function. How do you find it? You notice that the g dash pi is 0. Yes or no? G dash pi is going to be 0. If g dash pi is 0, it means the function is going to cease at that point, means it will attain its maximum value. And what is its maximum value? If you put pi there, that value will become 0, but this will become pi. So at pi, the function will attain the value pi. So it will hit this height, which is going to be called as pi, and at that point also it will attain its maximum value. After that, At 3 pi by 2, this g dash pi by 2 is what? G dash 3 pi by 2 is what? Negative value, correct? Means at 3 pi by 2, it has a negative slope. And what is the value of 3 pi by 2 of the function? This will go 0 and this is minus 1. It means it has to go down to hit minus 1 at 3 pi by 2. It means the graph suddenly drops like this. It will hit the x-axis somewhere between pi and 3 pi by 2. It will come down to attain the depth of minus 1 at 3 pi by 2. And it will go down again. But what will happen after this? At 2 pi, what will happen to the function? At 2 pi, again you can see that the g dash 2 pi is 0. It means the function gx will attain its minimum value. And at 2 pi, what will happen for the value of the function? At 2 pi, this will become 0 and this will become minus 2 pi. So it will go very low to get the depth of 2 pi at 2 pi. And from there it will start rising. But in this whole process, what you are observing, and I'm not going to draw the entire graph till 6 pi because we can analyze from here only. So what the analysis we can do, you can see that between pi and 3 pi by 2, I have one point here when the function derivative, with the fx function derivative, the gx is nothing but the f dash x times some quantity. But that some quantity is immaterial. So now I can say directly for the f dash x, means the function derivative is changing its sign from positive to negative. Because before that point, the function was, means the function derivative, the gx was above the x-axis. It means all the values are positive. And after this point, it is going down, it means its value is negative. It means this point must be the point of local maxima for the original function, correct? So I don't care what the point is, but from pi to 2 pi, we got one point of local maxima. Again, the same repetition of the graph will happen. Why? Because at every pi and every 2 pi, means every odd pi and even pi, this function gx will attain its maxima or minima. And in the process of this attainment, it has to cross the x-axis once in a while, correct? And so between pi and 2 pi, we got 1 maxima. Again, we get 2 pi to 3 pi. Again, it will cross. This is going to be, let's say I'm writing here, okay. So between pi and 2 pi, we got, between 2 pi and 3 pi, we got, and let me show you again, 3 pi to 4 pi, and again 4 pi to 5 pi, and then 5 pi to 6 pi. So here we got one point at which the function is crossing the x-axis. Here one more point, 2, 3, 4. So 1, 2, 3, 4, 5. So there are 5 points at which the gx is crossing the x-axis. It means we have to only see what is the first point it was crossing. So it's got crossing from positive to negative. So this will be the maxima. So this will become minima. Again, this will become maxima. And again, this will become minima. And again, this will become maxima. So I have to find how many maximum points you have. So of course, there are 3 maximum points. Number of points of local maxima in the pi to 6 pi. So which are those? Here it is. There's a maxima here, here, and here. And between 2 pi, and you can see that from here, 4 pi to 5 pi, we are getting the minimum value. What they're asking, there is other option. Number of points of local minima of f in the interval 2 pi to 4 pi is 1. So 2 pi to 4 pi, no. 2 pi to 3 pi, there's one minima I'm getting, and 4 pi to 5 pi, I'm getting one more minima. So 2 pi to 4 pi, yes, there's one minima here. Yes, because 2 pi to 4 pi only getting here, so there's one minima here also. All right. So in this way, we can also do this question. I'm not against that solution of this approach, the cos x tan x minus x, but just I wanted to convey my point on this question. So I hope it helps and you found some interesting solution, and See you in the next video with some other question. Till then, stay math active.